Hello there! In this tutorial, we are going to be creating this level in Pygame with the tiled editor. So you are going to learn how to use this editor to set up a level and import it into Pygame. And the only requirement to follow along for this tutorial is that you know basic Pygame. And if you don't, I would recommend you to check out my introduction to Pygame. That is going to explain all that you are going to need. However, this video is also part of a series. So while you don't need anything for the first part, the second part of the video is about integrating a main player character into this level. And to follow that one, you will need to have watched the first part of the series. But that is going to come much later. If you just want to understand how to use the tiled editor and how to import all of this into Pygame, the first part you can just watch by itself. So with that, let's install tiled and let's create a level. All you have to do is go to the website of tiled, click on download, and then it links you to the correct site. Now on here, it does suggest the price, but you do not have to pay it. You can get tiled completely for free. You just have to click on the link above. And on that page, you get different options depending on what operating system you have. In my case, I have Windows 10. And then you download an installer, and if you click on that, you get this kind of dialog. And then here, you just click on next, and it basically does all of it for you. And then by the end of that, you can just launch the program, and then you are going to see something like this. A whole lot of gray, but in the top left, you can see these different options here. And you have Open Project, Save Project As, Add Folder to Project, Open File, New Map, and New Tile Set. And in our case, the only two options here that really matter are New Map and New Tile Set. Anything else we can ignore. And let me explain what those two actually do. And this is also going to detail how tiled works in general. So we have a map and a tile set. And the best way to understand them is to think of a painter. So if you want to paint something, you need three different things. You first need a canvas, then you need a brush, and then you need some colors. And in this analogy, a map would be the canvas to draw on. Then a tile set is going to be each individual color. So where we are going to get our information from. Now for the brush, we first have to open a project. And essentially how we start is by creating a new map. So we are essentially creating a new canvas. So let me click on it. And now we're getting a couple of different options. We get orientation, tile layer format, and tile render order. And all of these options are basically perfect by default, at least in our case. So I would recommend to leave them exactly as they are. Below that, we have map size and tile size. And for the map size, you can set the width and the height of your project. In my case, I have 60 tiles for the width and 11 tiles for the height, which is already what I want. So I'm going to leave them as they are. And if you follow along, I would recommend to use the same dimensions. It becomes important later on. And then we have the tile size, which is the size of each tile, which in my case is 64 by 64, which I'm also happy with. So now that I have all of that, I can click on Save As. And now Tiled wants me to save all of this somewhere. And in my case, let me show my folder structure. So I have code, graphics, and levels. And I want to store all of this in levels. And in here, I have one folder called 0, then level data, and tile sets. And for now, I just want to save this in level data. And let's call it level 0. And let me save it. And now we can see a proper tiled setup. So let me explain what we are going to see really quick. Although all of this is going to make much more sense when we actually use it. But let me go over the different panels really quick. Now the most important one, right in the middle, this thing, this is your actual level. So this is the canvas we are going to work on, or well, the map. Now besides that, on the left side, we have our properties. And in there you can get some information in terms of what you're working on. So right now we're looking at the map. You can get tile width and tile height, the width of the level, the height of the level, and basic stuff like that, although that's not too important in our case. Then on the top, you can see a couple of basic selection tools. The really important ones are these couple here. And the one we are going to use the most is this one here. And this is called a brush, which, well, is going to be used as a brush. So think back of the analogy I used a second ago. This is literally going to be our brush. But there's also a paint bucket, a selection tool, and quite a few more. But we're going to see in a second what they actually do. Then on the right side, you can see layers here and tile sets here. And for the layers, all it really means is that you can draw on different layers. So if you want to put stuff on top of each other, you would use different layers. And then the tile sets is the actually important part where we are going to get different colors that we can draw with. And this is actually what I want to do. So let me click on new tile set. And in here, we are going to get a new dialog. And the one important aspect you need to know here is this type. And if you click on it, you get two options, based on tile set image or collection of images. And you're going to see later on what that actually means. But for now, I want to create a tile set image. And to create that, I need an image. So below that, I have to click on Browse. And if I do that, it brings me to my file structure again. And I want to go to my graphics, and in there, I have a folder called Terrain. And let me make all of this a bit larger. In here, we have one file called Terrain Tiles. And this I want to open. And now Tiled is going to give me quite a few more information. First of all, it now gave me a name, Terrain Tiles, which I'm happy with. And it gets the name from the name of the file. And then you get tile width, tile height, margin, none of the stuff we really are going to need. So now this I also have to save. And I want to save this in my tiled sets. And let's keep it with the name Terrain Tiles. So let me save it. And now you can see the actually important part. Now we have a tile set and we can select each of the tiles from what we have selected earlier. And what is also important, if you look at the top, we are now in a new tab called terraintiles.tsx. And here you can work on your own tile set in quite some detail. But I want to instead go back to my level, so the first tab. And now what I can see for my tile sets, I have the tile sets still available. And well, what I can do now is use this thing to draw. So let me just select the middle part here. And now I can use this to draw and select different elements and draw them wherever I want them to be. And obviously right now this looked terrible. So instead, let's do this a bit more deliberately. And first of all, I want to zoom in. So with Control and the mouse wheel, you can zoom in. And let me go right to the start of the level. And then here, I have to have my stamp brush selected. So this thing here at the top. And with that, I can just select different parts of my tile set and draw them on the screen. And another important part here, you can also keep on holding your mouse button down and then move along. And that way you keep on drawing different elements. And well, this is then how you would create the basics of a level. So the stamp brush here is the tool you are going to use the most. But there are quite a few more. So let me go over some you are going to use a lot. The first one is the paint bucket tool or the bucket fill tool. And if you select this one, you can fill an entire level with a certain color or well, a certain tile. So I can use this to draw, well, one tile over the entire map. And this tool is context aware. So let me go back a tiny bit. So this tool selects also similar tiles. So if I hover over the platform we just made, it also can tell if we have similar tiles, which is quite powerful. Then besides that, we also have an eraser. So if you want to get rid of something, you can just use the eraser. And finally, we have a rectangular select. And you can use that to select the rectangle, I guess. And if you have that, you can use Ctrl-C. And if you then use Ctrl-V, you are copying entire sections of your map. And you can then use them and place stuff somewhere else. And that is literally all we needed. So if you left click then, this stops working. So there are quite a few more tools, like the terrain brush or this magic wand, or well, all of this stuff here. And tileset is really, really powerful. So you can use it for quite some more things. But in our case, we don't really need it. We can just rely on the basic tools and create our level with that. So I am just going to rely on these tools. And well, let's actually use them to set up our level. And all I really want to do is to select different parts and then create the level. So let me rebuild this platform. And now I guess I am going to speed up the process here to make this not as boring. But this would probably be a really good exercise for you. Try to use the level editor to set up and fill out this entire map with platforms, or about whatever you want to have on the map from this section here. Alrighty, so this is going to be my basic level. Now, in your case, this is probably going to look slightly different, but in here, you can set up your own level. And an important thing to work on now is that we have to rename this thing, because right now it's called Tile Layer 1. And I want to call this Terrain. And the names here are going to be important later on when we import this into Pygame. So I would recommend you to follow along exactly with the naming convention. But with that, we have our first layer. So next up, we have to create another layer. And for that, you have to go to this icon here. Let me highlight it a bit better. This icon here. And if you click on it, you get a couple of different options. We have tile layer, object layer, image layer, and group layer. In my case, the only important one is a tile layer. And this tile layer I want to call coins. And well, what I want to do in here is to add all of my coins. And to create coins, we first have to import them. And that means we have to create a new tile set. And a new tile set you create by clicking on this icon down here, which looks identical to the new layer icon. And if you click on that, we get the same dialog again. And in this case, I want to click on Browse again, go to my graphics folder, and then there I have a folder called Coins. And if you click on that, let me maximize it, we get a folder called Gold, Silver, and then Coin Tiles. And Coin Tiles is what I want to import. And now again, we have our coin tile name, and I want to save all of this as its own file. And this I want to save again in tile sets. And there I still have my terrain tiles. So now I save it. And now I have my two coins. So I have a gold coin and a silver coin. And all of this again happens in a new tab. And well, if I go back now, I have a new tab in my tile sets, which is called coin tiles. And then here I have my gold coin and my silver coin. And now, before we are placing all of this on the map, there's one important thing to consider. So right now I have my coin selected, so I can select my gold coin and draw coins all over the map. And I can even draw on top of the existing tiles. So the existing stuff does not get deleted. However, let me undo all of this. If I have my terrain tile selected and I draw over stuff, I can't really draw over it because the coin replaces what we have drawn previously on the terrain map. So let me undo it. And the important thing here is what layer you have selected really matters. And also, the hierarchy of these layers really matters. So let me draw a coin again on top of these tiles here. And let me zoom in a tiny bit. So right now you can see that the gold coins are on top of the terrain. And that is because the coins here are on top of the terrain in our layers. But if I click on this down arrow, now my terrain is on top of the coins, so you can't see the coins anymore. So I want to undo this, and now I can see my coins again. So this layer setup here is incredibly important, and make sure to always be on the layer that you actually want to work on. And it is very, very easy to work on a layer you don't actually want to work on, which might cause quite a few problems. So it's an important thing to consider. But all right, let me delete the coins I have put there. And now that we have covered that, on my coin layer, I want to place a couple of gold coins. And let me place one here, one here, one here, and I guess one here and one here. And then I can place some silver coins as well. Let's place them here, here, and here. Let's say here, here, and here, and a couple all around. And it literally doesn't matter where you put them. It's really what kind of level you want to create. In my case, I am happy with this. So now we already have two different kinds of layers. We have coins and we have terrain. And you can also click on this eye level to hide the entire layer. And you can lock the entire thing as well, in case you want to make sure you don't change it by accident. And there's one more tile set I do want to import. So let me go again to the bottom and create a new tile set. And I again want to go to Browse and go to Graphics. And there we have a folder called Decoration. And in there we have clouds, grass, sky, and water. And I want to look at my grass folder. And in here we have one long file called grass. And let me open it. And let's call this grass tiles and save it along with our other tile sets. So in the same folder we have coin tiles and terrain tiles. And now you can see different grass tiles that all look very, very similar. So if I go back to my main level, and also if you have a star in this tile here, it means you haven't saved. So I would recommend to press Ctrl S fairly regularly. Tiled has a tendency to crash once in a while. Not very often, but usually when you want it the least. So do save regularly. But now I have my grass tiles. And all of those look identical. And well, it would be kind of a pain to select each individually and place it somewhere on the map. And also right now I'm on terrain and I don't want it on here. Instead, I want to have a new tile layer that I call grass. Because later on this layer setup is going to be important and grass should be on its own layer. You're going to see later why this is important. But the important thing I want to do now, instead of placing each of these grass tiles individually, I want to be able to select all of them and then only place one of these at random. So right now I have selected all of them. And if I go to my map, I can place all of them at once. And this would already make my life much easier, but well, we would always get the same kind of setup. So instead what I can do, I can click on these dice up here, which is called random mode. And what that means is that Tile is going to pick one of these selected tiles and place them. So now, if I just drag this along, we get grass with random tiles from our selection. It's very hard to see because our grass looks identical, but let me zoom in a tiny bit more and place a tile grass now. And I place stuff on top of each other. And every time I click, we get a different grass tile set. Which then means I can just go around my level and place individual tiles, and it is always going to be random. And let me just go around and place some tiles. I don't want to have grass everywhere, but at least for most places, it's probably going to make the level look better. And alright, with that, we have some grass. But now the level still looks fairly stale because we don't have any crates or palm trees, and we also don't have any enemies. So I want to import all of that. And let me start with the palm trees. However, we have a problem with the palm trees here because we do not have a tile set for the palm trees. So let me actually open the folder with the palm trees. So here I have my folder with the terrain, and in there I have palm BG, which is a background palm. Then I have a palm large, which is different animation frames. So all of this should be the same palm. And then I have a palm small, and then I have a crate. But all of these are just individual images. It's not a tile like terrain tiles. And as a consequence, we couldn't just import all of this as a tile set. Instead, if I go back and I want to create a new tile set here, I cannot select based on tile set image. Instead, it's a collection of images. And now we have to select a name. And let's call this palms. And save as again. And again, I want to put this in my tile set. And now we get an empty looking file. And essentially what we have to do now, let me open up my folder again. In here, we have to drag and drop different things. So let me start with my palm small. In here, we have the different animation frames, and I just want to grab one of them. Let's say small 1. And I just drag and drop it into here, and now I have it available. And I want to do the same thing for the other ones as well. So let's say large 1, and then I go back to my palm BG and BG palm 1. And there we go. Now I have a couple of different palm trees inside of my level editor. And now if I go back to my main tab, I have a palms tab in here as well. And now I can just select them and place them wherever I want them to be. But before we can do that, I first again have to create another layer. So let me create a tile layer, and I call this one FG palms for foreground palms, because we also have a background palm that are supposed to be on their own layer. But now, really all you have to do is to move these palm trees around like all the other tiles we have used so far. So let me place one here, place a larger one, and just place stuff all around the map. And I'm not going to worry too much in terms of how this is going to look, because that's not the part of this tutorial. But obviously in your case, if you want to make a nice looking level, you want to spend a bit more time in this. And you can also place some palms on the level as decoration, which I think looks very nice. So let me place one here and a couple around here. And let's say a few more at the start, one here as well. And yeah, I think that looks respectable. So now we have a bunch of different palm trees. And all of them later on in the game are going to be collidable with the player. But I also want to have the background palm trees. And those are just to be there for show. So there's not supposed to be any collision for them. So I want to create another layer. And let's call this one BG palms. And this should be all the way at the bottom, because it needs to be behind everything else. And now, if I zoom back in again, I can drag my palm wherever I want it to be and add some decorative palms to the level. And let me just place it all around. And in here, again, just place stuff wherever you think it looks good. It's really entirely up to you. And all right, with that, our level really is starting to shape up to look quite good. And that is actually all the tools you are really going to need to set up any kind of level. And let's actually do an exercise to practice this. In the terrain folder, there's a crate file. Import this one and then place the crates all across the map wherever you think they're looking good. All right, so the first thing we have to do is to create a new tile set, and it's again a collection of images. And let's call this one crates. And let's save it. And again, I want to go to my tile sets and save it in here. And now again, I have an empty thing. And let me go back to my folder. And in the terrain folder, we have a crate. And I just want to drag and drop it into here. And well, that's all we needed. So now if I go back to my main level, there's a new tab called crates. And now I can select my crate. And let me zoom in a bit again. I can just place a couple of crates all across the level. And well, again, wherever they look the best. I guess this one here, I'm not sure if the player could jump on this because it is quite high. So let me actually move the coin a tiny bit up. So to my coin tiles, I want to delete this coin and place a new one right on top. And this should be a good distance to jump for the player. And this one here should also be doable. And let me place a coin here as well. And now I realized I did make a mistake, because we have not created a new layer for the crates, which, well, would cause problems later on. So I pressed Ctrl Z a couple of times to remove all of the crates. It's really a very easy mistake to make. I want to create a new tile layer and call it crates. And this I want to be behind the grass. And well, now let's do all of this again. Let's place a couple of crates all across the map. We can put one here as well. Let's place one here, let's place one here. I guess one there. And then let's place one here. And now let's move the coin again, one place up. And really make sure you are on the coin layer. Otherwise, you are going to end up in problems. And I placed one here as well. And let's go back to my crates. And let's place a couple of crates in here as well. Not there. And okay, so with that, we have a level that is really starting to look good. And really make sure you always draw stuff on the right layer. It is a really easy thing to mess up. And I guess the easiest way to double check this is if you hide specific layers, you know what's going to disappear on the map. And in my case, this is looking quite good. So yeah, I think this is all working. But now we are going to need two more things. Number one is the enemies, and number two is the player. So where I want to spawn my player and where the level is supposed to end. And this is also going to be a tile. So let me explain, and let's do this with the player. So I first of all want to create a new tile layer that is for the player. And let's place it all the way at the top. And now I also want to create a new tile set. And this is going to be a tile set image. And let me browse. And if we go to graphics, there's character. And if I zoom in a bit, there's a file called setup tiles. And if we open that one, I can save it as tile sets for the setup tiles. Let's actually call it player tiles. That makes a bit more sense. And now we have start and end. And well, in my level, I want to use these two player tiles, setup tiles, to determine where my player is starting and ending. And well, I just want my player to start here, and then the end of the level should be, let's put it here. And that way I can control exactly where my level is going to start and where it's going to end. And now finally, I want to import my enemies. And this is also going to be on its own layer. So I create a new layer, and this one I call enemies. And let's place it below the player, although it really doesn't matter all that much. And now I want to create a new tile set again. And let me go to graphics, and there's enemy. And there's also a setup tile. And let's open this one, and let's save it. And again, I want to go to my tile sets. This is going to be the last one. And let's call this the enemy tiles. And now we have something weird. We have our enemy, and then we have a red square. And for now, let's focus on the enemy. So I go back to my level, and now I can just place where I want to have an enemy. And let me select this one here. Now I can just place the enemies on the map. So let's place one here, let's place two here, let's say one here and one here. Then I can place, let's say two here. And I guess now it looks a bit weird that they are in front of the palm trees. So let me put the enemies below the palm trees. And that is looking better. So now we have our enemies on the map. So what is this red square for? So let me explain. Basically, in the actual game, I could approach the enemy movement in two different ways. I could give them really complicated collision detections so that, let's say this enemy here, I could check if this guy's on the floor or if he's in front of a cliff, like here, or I could check if he's colliding with a box. I can do lots of different things. However, this would also be really complicated because I would have to add a ton of code for the different collisions and to understand what the enemy is doing, which would be a lot of code. So I'm not going to do that. Instead, what I'm going to do is I'm going to only move the enemy either left or right. So they don't have any gravity, they don't have any proper collision detection, they don't really do anything besides moving left and right. And then this red rectangle here is to give them a constraint. So all I'm really going to do for the enemy, I am going to move it left until it hits an obstacle, and I'm going to put an obstacle here. And if that's the case, he's moving right again until he hits another obstacle. So I'm going to put one here as well. And that way, our enemy movement is going to be significantly easier because we don't have to worry about gravity, proper collisions, all of that stuff. And for that, we have these red squares. So I'm going to create a new tile layer, and I call this one constraints. And now I'm just going to place these constraints wherever I want this enemy to turn around. And this I can do for all of them. So there's going to be one here, and one here, and one here, then one on top, and let's say one here, and then there's one here, and not there, here. So this is going to allow me to specifically tell where an enemy is supposed to turn around, which gives me a lot of control over where stuff is going to be. And with that, we have our entire level setup. So this actually works out really fast once you have the basic files. And once you have all of this, you can also create new levels really, really fast. It doesn't take all that long. So now what we can do, if I save the file, I can go to File and Export As. And then again, I end up in my folders. And then here, I want to go to Levels, and this is going to be level 0. So in here, I want to save all of this. And now you might be wondering, what are we actually going to save? So let me open all of this. So I go to my level, to level 0, and in here, we have what's called comma-separated values, or comma-separated value files. And let me open the one for terrain. And in here, you can see something really strange. We get a whole bunch of -1, and then sometimes we get a 0, we get a 4, we get a 5, 6. So what do these numbers mean? And well, the answer is quite easy. Let me go back to tiled, and let me go to my terrain tiles. And let me zoom in a tiny bit. So if I select the top left one, in here, if you look at the properties, you can see ID of 0. And this is what is actually being exported. Literally, all we are exporting, let me actually go back to my actual level. So what we are actually exporting is not any kind of image or anything of that sort. Instead, all what we are exporting is the information for each of the tile. So on the top left, this tile here would be -1. This one would also be -1 because it's empty. However, if we get to a tile like this one here, this would get a tile of 0. And it would get 0 because if I go to my terrain tiles and select 0 here, you can see in the top left, we have an ID of 0. So this one here would have an ID of 0. The one to the right of it, I think is going to have an ID of 1. And then each successive one is going to have an ID of 1, 1, 1. And the next one is going to have an ID of 2. And let me actually double check. So if I click on them, this tile here is going to have the ID of 1 in the top left. And then for the one corner tile, we have an ID of 2. So this one here works out quite well. And this way, we can tell exactly where stuff is supposed to be. And we are going to do this for literally every single one of these tile layers. So we have one for the terrain layer, one for the player layer, one for grass, palms, enemies, crates, and so on. So we have quite a few different layers to import into Pygame. And well, this is going to be the next part. And in here, we have to address a couple of different things. So let me go through what we are going to do. Number one, we have to import the comma-separated value file into Pygame. Then number two, we also have to import all of our images. And we are going to start with the terrain file. That's the most complicated one. So what we are going to do here is to import a tile set into Pygame and to slice it into parts that we are going to need. And then number three, we are actually going to use those bits of information to lay out the level in Pygame so we can see it. But that is going to be quite a bit of code. But let's actually go into Pygame and let's have a look at this. All right, so here we are in Pygame, and right now we have a very simple setup. So if I run this code, we get a pretty basic looking screen that has a screen dimension of 1280 by 720. And it shows plain black, and we are, well, not doing very much. So first of all, we have to add a couple of things here to make this a bit more responsive. So I know right now, for example, that my screen is not 720 pixels high. So I want to adjust this a tiny bit. And for that, I'm going to create a new file. And let me save it. Oh, and by the way, if this is our level setup, I am in the code section. And in there, I want to create a settings.py file. And in here, I first of all want to create a vertical tile number. And in my case, this is 11. And this is the same number I picked earlier when I created the map in tiled. And another number I picked in there is the tile size. And in my case, this is 64. And now with that information, I can get a screen height. And really, all that is going to be is my vertical tile number multiplied by my tile size. So that way we are going to have the same height that we created earlier in the tile map editor. And then besides that, I also want to get a screen width, which can just be a plain number. In my case, 1200. But in here, choose essentially what works best on your computer. It doesn't matter all that much for the functioning of the game. But with that, I can go back to my main file and from settings, import everything. And this way, I can still keep my screen width and screen height. So these two variables here now come from my settings file. And as a consequence, I can get rid of the ones I've declared inside of this file. So if I run all of this, we still get the same black screen. The only difference now is that this is not 720 pixels high anymore. Instead, it should be 704 if my math is right. But well, you can't really see that, and it doesn't matter all that much. But now we have our basic setup for the window. Next up, we can actually start working on the level. So before we import anything, we first need some kind of class that organizes our game. And for that, I want to create another new file. And this one I'm going to save as level.py. And the first thing I have to do in here is to import Pygame, as always. And then I just want to create a class called level. It does not inherit from anything else, but we do need an init method, which is actually going to become quite long. And in here, I want to specify a couple of parameters. The first one is going to be the level data. So the actual information that we created earlier in the tile map. And we are going to store all of that in a dictionary. I'll show you later how that is going to work. Besides that, I want to get a surface, so the display surface of our window. And that is actually all we need for now. It wasn't actually all that much. And the first thing we have to do in here is to create self.display surface. And this is just going to be the surface we pass into here. And then besides that, I want to create another method. And this I will call run. And in here later on, I'm going to run the entire game, or well, the entire level. But for now, we are just going to add pass in here. So this is a very basic setup. Now, what I want to do with that, in my main file, I want to import from level import level. And now I can just create an instance of this level. We're going to pass the arguments in there in just a second. And now in here, I can just call level.run. And this way we can write our entire game logic inside of this run method. And we don't have to add a ton of code in here, which is going to make our life a bit easier. So now we have to figure out the arguments for our level. And let me just copy them so we can work with them a bit more easily. So in here, we need the level data and our surface. And the surface is the easier part because literally all we want is this display surface or our screen. So really, we just have to pass it in here and we are good to go. This part is very easy. So I literally just going to type screen in here. But now we are going to need some level data. And what this is going to be is essentially a dictionary with the link to all of our CSV files, because they basically contain the blueprint of our level. And this is going to be quite a complex dictionary. So I'm going to store all of this in another separate file. And let me save this as game data.py. And in my case, this is going to look something like this. So we start with a dictionary, and the first key is called terrain. And terrain has a fairly long file path. So first of all, we are going up one folder, then we go to levels, then to the folder 0, and then we pick the level 0 terrain.csv. And let me actually illustrate how this is going to look in the actual folder. So here you can see the code that we are working with. So we have game data, level, main, and settings. And from there, I want to go one folder up. And that is going to be, in our code, this double dot. So if you ever add in your file path a double dot, you're going up one folder. So now we are in the parent folder where we have code, graphics, and levels. And I want to go to levels, then to 0. And now I have all of my CSV files. And the one we are looking at right now is level 0 underscore terrain. And that is this one up here. And well, then we are doing the exact same thing for all the other files as well. So this is a dictionary that targets all of our CSV files. And then this is what I want to pass inside of this argument here. So first of all, I have to import it. So from game underscore data, import level 0, and just pass it in level 0. And for now, let's just try if this works. And we don't get an error message, which is generally a good sign. Cool. Now, first of all, before we continue, let's talk about why this is helpful. So in this case, you might be wondering, why do we store all of this data inside of a dictionary? And the answer here is organization. Later on, when I have different levels, so in a future tutorial, this setup allows me to just replace this argument here and get a new level. So later on, this is not going to have just level 0. There's also going to be level 1, level 2, level 3, and so on. And all I have to do to load each individual level is to load this class here and pass in a different argument. And that way, it's going to be very easy for us to organize our game. And especially after creating an overworld, organizing our game like this is going to make our life much easier. So with that, we have our data in our class. So now I can close the game data file and go to my level. I can also close settings. We don't need it anymore. So now in here, we first have to figure out how we can actually access our level data. And that is then going to be about how can we import a CSV file. And in here we are lucky because CSV files are very commonplace for basically any kind of database. So Python has lots of tools inbuilt to make all of this work. And there literally is a whole inbuilt Python module called CSV. So this we can use very well to make all of this work. But let me talk through how we are going to approach this. And let me do this straight in code. This is going to be best. So here we are back in the level class. And what I want to create, let's start with the terrain and let's call it terrain layout. So in this, we just want to import our CSV data. And for that, I want to create a new function. And this I called import CSV layout. And into this, we pass one argument, and that is our level data. And in there, we want to get the terrain key, or the value associated with this key. So now we have to create this file here. And since I am going to use this function quite often, I'm going to put this in another new file. And this I call support.py. So in here, I want to define a new function that is called import_csv.layout, I think I called it. Yes. And this one is going to need one argument, and let's call it a path, because this is literally what we are going to get. So this data here is going to give us a file path to a CSV file. And this is what we want to import. So now we have to figure out how to import a CSV file. And for that, we are going to need the, let's call it import CSV. And this module will give us a lot of different functionality to work with CSV files. Although we don't really need all that much. We only really need one function inside of here. So I'm not going to import all of CSV. Instead, from CSV, import reader. So this allows us to read a CSV file. And this is really all we want to do. For example, we don't want to write a CSV file. So now we have to figure out how to actually open this CSV file. And you are doing that with the command with open, and in brackets, you have to pass in the path you want to target. So this is path in my case. And now we need as map. And essentially what this map here is doing is that it functions as a variable that we can work with that represents this path here. So right now we're essentially storing all of our CSV inside of this map. And this allows us to work with this data quite a bit more easily. And all of this is actually vanilla Python. So right now we could run this without importing anything. So now we have the CSV file available in our Python document. But now I actually want to read the file and convert it to something in Python. And I want to store all of this in a variable I call level. And for that, we are going to need our reader method. And in here, we have to pass in two different arguments. The first one is the CSV data, and then what is called a delimiter. And well, our CSV file is literally just this map. That's the easy part. Now with that, what's a delimiter? And the answer here is actually quite simple. All Python really wants to know here is what we are using to separate each individual data point inside of our CSV file. So in our case, this is literally just going to be a comma, because we have a file type called comma separated value. So this should be quite obvious here. But if you had a different kind of file type with a semicolon or a dot or just a space, you will pass something else in here. But this is basically all we needed for this part. So now we have imported the CSV file. And let's actually print what we are getting here. And I hope I get all of the file paths right. So now I can go back to my level file, and since we are running this, we should be seeing something. So back in my main file, let's try this, and we are getting an error because import CSV layout is not defined. So this is quite easy because I did not import this thing here. So from support, import CSV layout. So now let's try this again. And now we can see at the bottom, CSV reader object at 1 point in our memory. So at the very least, we know that we are not getting an error. That is always a good start. But obviously, this isn't particularly helpful. But now, this variable here, we can loop over. And this is exactly what we want to do. So what I want to do is for row in level. And now let's actually print our row. I think we should be able to see what's in there now. And there we can see all of our data points we have created earlier. So for example, here we can see our first row, then our second row, and all of these are -1 because there's no tile here. However, if I go a bit further down, we can see a 14, we can see 12, 13, and quite a bit more. So we know we have the data correctly imported. So that's a really good start. But now I don't just want to print it. Instead, I want to put it into something else. And really what I want to do is to create first a new variable that I call terrain map. And this is just going to be an empty list. And then inside of this for loop, I'm going to get my terrain map and append each row. And there is one slight complication, because this data here, I want to make sure to convert this into a list, which is going to make it easier to work with it. The data type can sometimes be a bit finicky. But if we're importing like this, all we get at the end is a list where each row is one row of our game. And that is exactly what we want. So at the end of all of this, I can just return my terrain map. So now when I run this function here, all that's being imported is the layout that I want to work with. So in my level class, let's print this in here. So terrain layout. And now let me run all of this. And now we can see, let me close this. Now we have imported all of our data and we can see it inside of our level class. Obviously right now, this, well, doesn't really look that feasible because it's just a crazy long list. But we know we have it. That's a really good start. But now we have to convert this to something that we can actually use in Pygame. So let me talk through what I am going to do. Right now, we essentially have a table of where stuff needs to be. So we know, for example, that in the top left corner at position 0 and 0, there's supposed to be nothing. And then right next to that, so in position 0 and 1, there's also supposed to be nothing. And then further down, let's say at position 10 and 3, we want to have a tile with the ID of 0. So we know how the tiles have to be in relation to each other, but we don't know how these IDs translate to a position on our Pygame screen. Fortunately, that is very easily done, because all we have to do is to multiply the X and the Y position by the tile's size. So for example, the top left tile is at position 0 and 0. This one stays exactly the same. However, the one right next to that, with the row 0 and the column 1, this one should be at position 0 and 64, since each of our tiles is 64 pixels high and 64 pixels wide. So really, all we have to do is to multiply the column by 1 and the row by 1. And that way, we are translating the table position of our tile into the actual position on the screen. And then we can use this position to create a sprite with a size of 64 and 64. And that way we get our entire level. And if you followed the earlier tutorial, there we had a list with strings inside. And this was basically the same kind of data we have now, except in a more basic setup. But really our CSV data is very similar compared to that list with strings. So the logic here is going to be very similar. But let me go through this step by step and let's actually implement all of this in code. So here I'm back in my level class and I want to get rid of this print statement here. And instead, I want to create a new sprite group. And let's call this one terrain sprites. And in here, you might be tempted to use something like pygame.sprite.group. But in my case, I am not going to do that. Instead, I'm going to create a function that is going to return a sprite group. And let's call this one self.createTileGroup. And this one, I do want to be part of the level class because this is really important for the level. But in here, I want to pass in 2 bits of information. First of all, I want to put my terrain layout in here. So I know what the blueprint for this layer is going to be. And besides that, I also want to give it a string, and I'm going to call this terrain. And this terrain is essentially going to be used so we can figure out what graphics we are going to work with. So for example, for this terrain layout, we know that it is for the terrain, but Pygame does not. It just sees a CSV file, or well, the data from a CSV file. So we don't know if this is from the terrain or not. And let me illustrate why this is important. All right, so here we are back in the tiled editor. And one thing that is really important that I didn't show earlier is, let me click on one of the tiles. So right now we have here our terrain tiles, and you can see in the top left, this one has the ID of 0. So this is kind of what we saw earlier, that if you click on 1, 2, 3, and so on, you always get the proper ID for these tiles. And this by itself is working really well. However, now let me open the coin tiles. And now if I click on the golden coin, this one also has the ID of 0. And then if I click on the silver coin, this one has the ID of 1. So essentially the problem here is that when Tiled is importing these tile sets, it always starts at 0 and then goes upwards. And if we have different graphics, it always starts from 0. And this is a massive problem for us, because in our CSV files, we want to clearly separate what ID belongs to what tile. And if you have multiple IDs with 0, for example, and that could mean a golden coin, some grass, a terrain tile, a setup file, we would end up in a ton of problems. So we have to specify what kind of graphic we are looking at. This is really important. So back in my code, this terrain is really just there to make sure that we are looking at the terrain graphics and not at the coin graphics, not at the enemy graphics, the terrain graphics. And this is the information that we couldn't get from this terrain layout here. And this is why we need this argument. So I hope that makes sense. But now let's create this method. So define create tile group. And in here we need self, we will need the layout, and we will need the type, I called it. And now essentially what we have to do is to create a loop that will cycle through this terrain layout. And then whatever we create in there, we want to put into a sprite group. So by the end of this loop, we can return a sprite group in here. So the first thing that we have to do in here is to create a sprite group. So sprite group, and this is going to be pygame.sprite.group. And towards this group, we're going to add all of our sprites and then return the sprite group at the end of this loop. And well, now we just have to cycle through this layout. So I want to go for row in layout. And this is going to tell me what my row is going to be. And let me actually print this row and see what is going to happen. So back in my main file, let me run this. And now if I close all of this, now I can tell this is my first row, this is my second row, this is my third row, and so on. Or well, this is a row with the index 0. But now we have a problem, because while I can get the information of what is inside of this row, what I really want to know is what the index of this one here is going to be. So the information I want to get is that this here is going to be row 0, this is going to be row 1, this is row 2, and row 3, and so on. So right now, this information doesn't help me all that much. But, well, for that, we can use the enumerate method. So let me put this into brackets, and I want to get the enumerate method. And in here, I want to get my row index and my row. And essentially, all that the enumerate method does is it tells us inside of this loop on what index we are on. So the first index would be 0, then 1, then 2, and so on. And let me actually print what we are going to see. So I first want to see my row index and then my row. And now let's try this. And now I can see that for row 0, I have this row here, then I have row number 1, and then I get all of this. And this is then already going to give us the Y position of our tile. So really, all we have to do is multiply this by 64 in our case, and then all of those would be in position 0, and all of these here would be at position 64, and then so on. So now we have the y position. And now inside of that, we have to create another for loop to get the x position. So now we want to loop over every single item inside of the row. And I think this would be a pretty good exercise for you. So if you want to code along, try to write the inner for loop to target every single value inside of the row and also get the index on what that row is on. All right, so what I want to do is to get for column index, and let's call it value, in enumerate, and now I want to get the row. So I want to cycle through every single item inside of this row, and I want to get the index and the value. And now inside of this, I can try to figure out where stuff is going to be. And well, all I have to figure out in here is, first of all, if an item is -1 or not. Because at position -1, we know there isn't supposed to be anything. So I can already start with an if value, ideally spelled correctly, is different from -1. And only if that's the case, I want to do something. But there's one problem here, that inside of this data set, we don't have numbers. Instead, we have strings. So this -1 here has to be a string of a -1. And this can be quite confusing. But when we import this, we don't import numbers. Instead, we import strings of numbers. Can be a very easy source of mistakes. But once we have that, we now know where stuff needs to be. So we have a row and we have a column. And from that information, we can get our x and our y value. And for the x value, literally all I want to do is I want to get my column index and multiply it by the tile size. And then for y, this is going to be the row index multiplied by the tile size as well. Right now, we don't have access to our tile size, but let me open it again from settings. So here in setting, we do have our tile size. So all we really have to do is from settings, import tile size. And that way we can access it inside of here. So alrighty, with that, we have some basic information. And now I want to target my terrain. So I'm just going to add if type is equal to terrain. And now in here, I want to create a sprite. And for now, this is just going to be a tile. And this tile is going to have 3 bits of information. The first is going to be the tile size, then x, and then y. So we know how big the tile is going to be and where it's going to be. And then I'm going to get my sprite group and add this sprite towards it. And let me put all of this a bit closer together. So for now, we are going to get a basic sprite, although we do have to create it. And for now, this sprite is not going to show a graphic. That comes later. For now, I just want to focus on the layout. So, well, we have to create this class here. So let me create another new file, and I'm going to save this one as tiles.py. And in here, we have to import Pygame. And then I want to create a class called tile. And this one is going to be a pygame.sprite.sprite. So we have to inherit from it. And in there, we have to create an init method that gets self as always, then a size, then x, and then y. And now on the first line here, as always, we need super.init to get the proper inheritance. And now in here, we don't really need all that much complicated stuff. So we first want to get self.image and then self.rect afterwards. And well, in this setup, all I want to get is pygame.surface. And then in here, for x and y, I just want to get my size and my size, since we, well, do want a square. And then self.rect is going to be self.image.get_rect. And then the top left is going to be at position X and Y. And there's one more thing that we are going to need, and that is self.image.fill. And let's say in my case for now, I want to fill it with a gray color. And if we didn't do that, the entire thing would be black. And since our background is black, we wouldn't see anything. So this is then going to be our very basic setup. And well, let's run this and see if we're getting an error. So if I run this, we are getting an error as always, because I did not import this tile here. But that is very easily done, because all I need is from tiles import tile. And now let's try this again. And now we can see that we can't see anything. And since we did not want an error, which we don't get, this is looking good. Cool. But now what we do have is a sprite group inside of here. And what we can do now is to get this self.terrain sprites, and I just want to draw it. And now I have to figure out what surface to draw it on. And in my case, I just want to get my display surface. And now, if I run this, there we can see the basic layout of our level. Obviously, it doesn't look particularly good right now, but you can tell it's the same layout we had earlier in our tiled editor. So this is a really good start. And next up, we can also make this entire thing scrollable, which is very easily, especially if you watch the first part of this tutorial series. But literally all you have to do, back in my tile, I want to give this one another method that is called update. And this one needs self and then is shift. And then literally all we have to do is self.rect.x plus equal that shift. And now back in my level, I can call self.terrain sprites.update. And now in here, I can just add in a number. Let's say 1 for now. And now back in my main file, if I run all of this, now we can see our level moving. Right now in the wrong direction. So let's go with -4 to see the entire thing. And now let's try this. And there you can see our entire terrain. And that is already looking really good. So this is working quite well. And now this number later on, we are going to change when the player is moving. So this should be an attribute of the class. And let's call this self.worldShift. And let me create all of this early on. And let's place it right here. And for now, it's going to be 0. And I think here it's going to be really helpful to use comments. So let's call this general setup. And this is going to be the terrain setup. This init class here is going to be quite long, because essentially what we have to do is what we have done for the terrain, we have to do for every single layer of what we created in the tiled editor. So this is going to be quite a few lines of code. But before we get to that, we first have to figure out one more thing. And that is, for my terrain, I don't want to have a plain color. Instead, I want this to have a specific graphic from our terrain tiles. So what we have to figure out is how to import this terrain graphic and then how to slice it up so we can use it in here. And well, let's go through this step by step in the code. Inside of this if statement, I first want to create a list with all of our terrain tiles. And let's call this one terrain tile list. And to get this list, I want to create another function. Let's call it import cut graphics. And this one is going to need a specific string, which is just going to be the path towards this image, which in my case looks like this. So we go one folder up, we go to the graphics folder, then terrain tiles, and then .png. And everything else is going to happen inside of this function. And I want to create it inside of my support.py file. I think it's quite good for the input functions in here. So let's call it define import cut graphic, and we need a path. And now the very first thing that we have to do in here is to fully import this graphic and put it on its own surface. So I want to create a surface, and this is going to be pygame.image.load, and we want to get the path, and don't forget convert alpha, so we don't tank the performance. Now we do know how big each tile is going to be. It's 64 by 64 pixels. But besides that, I also want to know how many slices I should take of the surface. And well, for that, I'm going to create two new variables. Let's call it tilenumx and tilenum y. And really all I'm going to do is to divide the width of this surface by the tile size. And that way I dynamically know how many tiles I am going to get. And this could actually be a really good exercise for you. Try to figure out dynamically how many tiles are going to be on this graphic. All right, so let's do it together now. The first thing we are going to need is the width and the height of this surface. So, well, I want to get surface.get size, don't forget the brackets, and this is going to return a tuple with 0 being the width and 1 being the height. So let me actually copy all of this and let's put a 1 in here. And then this, I just have to divide by my tile size for both of these statements. And now, right now, I don't have access to my tile size in here. So from settings, import tile size. And right now, this might return a double, which would be a problem. So I'm going to convert all of this to an integer. And that way, it's going to make my life much easier. So now I know how many tiles are going to be inside of this graphic, which is actually quite important. Because what I want to do now is for row in range tilenum y. So I go for each row in this image, and then for column in range tilenum x. So I am essentially going to use these two variables here to figure out how many tiles I want to get out of this surface. And this is actually going to be quite similar compared to what we have done in here. The only difference is that now we are not using the enumerate method for the simple reason that we don't need it, because this tilenum y and this tilenum x are numbers by themselves already. So I think in my case, tilenum y is going to be 4. So this tilenum y is 4. So if we use range, we are going to get the numbers 0, 1, 2, 3, and 4. And the same for tilenum x. And that way, we already know by the content of this variable on what index we are going to be on. So we don't need the enumerate method. And well, now we can just continue what we have done in here, because now all I want to get is the x and the y position. So I want to get an x and a y position. And well, all we have to do in here for the x position is to get my column multiplied by my tile size. And then for my y is going to be row multiplied by my tile size. And literally all we have done in here is the same thing we have done in here, bar some minor differences. So now we know what position we are on in this tile set, and also how much of a tile we want to cut out. So with that information, I can create a new surface. And this new surface is literally just going to be pygame.surface with my tile size and my tile size. So with this line here, we are just going to create a square surface that is 64 by 64 pixels. And onto this surface, I want to blit one specific part of our main image that we just imported. So this thing here, our terrain tiles. And for that, we are going to need blit. So let me explain what I am going to do. First of all, I want to get my new surface and then blit. And what I want to put on the surface is, well, my surface I just imported. So the surface I have put up here. And this I want to blit on this new surface. But I don't want to blit the entire thing. I only want to blit one specific slice that is 64 by 64 pixels. And this blit allows us to do, because now for the second argument, we need a position. And the position in my case it's just going to be X and Y. So right now we would be creating a massively too large blit on this new surface. But blit also accepts a third argument, and that is a rectangle. And this is essentially going to be a mask that we only want to cut out one specific part of this surface and not blit the entire thing. And in here we have to pass in a rectangle. So pygame.rect. And now the arguments we are going to need is the top, the left, the width, and the height. And width and height are both very simple because we just want the tile size again. And now for the top and the left, we also have this information. This is just going to be X and Y. And I think this part might be slightly confusing. So let me explain it on the actual terrain tile set. And this one looks like this. And literally all we have done is we first got a top left point, and then we picked up one specific slice of this tile set. So for example, for the first one, it looked something like this. And only this part we have blitted on a new surface. And we got this information by first getting this point here. So this was the row and the column. And then we multiply this by 64 and 64. So in this case, the state 0 and 0. And then the size of this slice we already knew. It's always 64 by 64. So then the next slice was going to be this one. The next slice was going to be this one. Then we picked up this slice and so on. Then we went to the second row and got something like this. And then we just kept on going and always picked up one specific slide and then blitted this slice on a new surface. That's literally all we have done in here. So I hope that makes sense. It does get slightly more complex. But, well, if you just look at this, it's not actually all that complicated. And this way we have a completely new surface with one specific part that we actually want. And now all we have to figure out is how to put this on its own list. And for that, I'm just going to create, let's call it cut tiles. This is going to be an empty list. And at the end of this function, I want to return my cut tiles. So now all we have to do is to get the cut tiles and append the new surface. And this is all we needed inside of this one class. So now I can go back to my level, and this time I am not going to forget to import this function. It's a mistake I make all the time. And now let's try all of this, and we are getting an error. And let me see what the problem here is. We are getting an import error that Python cannot import cut graphics. And this is a very common error. And usually what it means is that you misspelled something. So let's have a look. So in my level, I import cut graphics. And in my support file, I have called this import cut graphic. So the only problem here is this needs an S. And now let's try this again. And now we're getting another error. Name Pygame is not defined. Let's have a look. And, oh yeah, also another thing, we need to import Pygame. And now 4 times the charm, there we go. Now we can import all of this, we don't get an error message anymore. So this is a good sign. And now we have a list of our terrain tiles in here, available in the class, which is super useful. And now we have to figure out how to put this inside of this tile here. And well, that's actually very simple, because all we have to do is first of all to get a new tile surface. So I want to pick the right tile from this list depending on what value we are looping over right now. And in here we can approach this very intelligently, because in tiled in the ID, we always start in the top left and then go to the right. And once we reach the end of the row, we go to the next row and start from the left to the right. And in this function here, we have used the very same logic. So each index inside of this list is going to have the same ID that we created in tiled. So all we really have to do is to get this terrain tile list, and then in there, get an integer of our value. And this way, we automatically get the right tile, for the simple reason that tiled and the list returned by this function here are following the same naming scheme. And now the last thing we have to figure out is how to pass this tile surface into this tile here. And for that, let me go to my tiles.py file. And in here, I want to keep the tile class as it is with one difference. I want to remove the fill command. And instead of changing this class, I want to create a new one. And let's call it static tile. And this one now is going to inherit from the tile class. So instead of inheriting from sprite, we're going to inherit from tile. And tile itself inherits from sprite. Now, why am I going to do that? Well, later on in this tutorial, we are going to create lots of different tiles. So we have a tile for the grass, for the coin, for the enemies, for lots of different things. And all of these are going to share lots of similarities. For example, they are all going to have this update method here. And if I kept on creating new classes that all of these attributes in common, it would be quite a waste of writing. So instead, I'm going to work quite a bit with inheritance here to create the tiles. And that way, I'm going to save an enormous amount of writing. And in here, first of all, we are going to need the init method as always. And I need self. And besides that, I want to get a size, an X, a Y, and now I want to get a surface. And now the first thing I have to do in here is to get my super and then dunder init method. And now we are essentially initiating this class inside of our static tile. So I have to give it the same arguments. And I have all of the parameters, so I can just copy them and pass them in here. So now I have essentially copied this tile. And now I just want to make one individual change. And that is going to be self.image is going to be the surface. And that's literally all I had to do. So instead of copying this entire thing, I just copied this with inheritance and then changed one line of code, which is going to make my life significantly easier because we're going to copy this process multiple times. But now we have a static tile. And let me import it in our level. So static tile. And then the sprite is going to be a static tile. And now we still need tile size, X and Y. But now I also want the tile surface. And now let's try all of this. Let me run it. And we are getting an error. And the reason for it is that our super object got an init. So let's have a look. So in my tiles, all that I really did wrong was I forgot the brackets. And now let's try all of this. And we are getting something slightly weird. So we can see the top left tile, but nothing else. And I just realized I made one mistake in the support class. Because right now, this X and Y is wrong. It should be 0 and 0. And the issue here is that we always want to put the graphic on the top left of this new surface. And this did work in the top left because there X and Y were both 0. However, once we got larger than that, we always put the graphic outside of this surface, so it ended up being black. But now, once we have that, I can run this, and now we can see the entire level. So this is working very nicely. And now what we can do, I can set this world shift to, let's say, -5. And now let's run all of this. And now we can see the level going by very, very nicely. And this is looking great. And cool. So with that, we have imported one layer of our tile. Really, all we have to do now is repeat this process about 7 times, and then we are good to go. And as a matter of fact, the terrain tile list was the most complicated one, because for this one, we had to separate a graphic. This we don't have to do for any of the other layers, so our life is going to be significantly easier. But well, with that, the next big section is going to be to import all of the different layers. And in here, I am just going to repeat the same process, except in a slightly different way for each of them, because they all have slightly different requirements. So let's go through them step by step. And let's start with the grass tiles. Those are going to be the most similar to our terrain. And in here, we still have to cut some graphics and then put all of this on a new tile. And well, let's jump straight into our code and let's have a look at that. So here I'm back in the level and I want to add a new section here that I call grass setup. And literally all I'm going to do is create a new grass layout. And then I import CSV layout level data. And I've called this one grass. So essentially what we are doing, I just copy this, paste it in here, and then change a couple of names. But the underlying principle is identical. So this layout would give us all we need to place the grass tiles. So now we would need self.grass sprites, and this would be self.create tile group. We need our grass layout, and then in here I pass in the string grass. Again, the exact same thing what we have done here. And now in this for loop, I want to add another if statement. That if my type is equal to grass, then I want to first create a new grass tile list. And in here, I can just reuse this function. And the path in here is the higher up folder, then graphics, then decoration, then grass, and then grass.png. And once we have that, I can create another tiled surface. And this is going to be my grass tile list. And then I just pick the integer of the value. Literally the same thing that we have done up here. So this is again the very same setup. So just like we have done up here, we are essentially copying the same layout. And then finally, I can create a new sprite. And this is also going to be a static tile. So we need tile size, we need X, we need Y. And now we are going to need a tiled surface. And what we can do now is this line here, we can place all the way at the end. So that way we only have to call it once. And let me add a bit of white space in here so it's slightly easier to read. And well, this way we are going to have our grass. Now, the last thing we have to do is to actually display all of this inside of our run method. So let's call it grass and self.grass sprites.draw self.display surface. And then we also want to get self.grass sprites.update and self.world shift. And I guess the update method should always come before the draw method, although it's not strictly necessary. And okay, this should be working now. Let's try. So my main method, I'm running this, and now we can see the grass. This is looking very nice. So with that, we have our terrain and our grass. Next up, I want to work on the, let's say the crates. That's not how you spell crates, that's how you spell crates. And in here, same thing, we have a crate layout, and this is going to be import CSV layout, level data, and in there we have a key called crates. And let me just spell this properly. And then self.create sprites is going to be self.create tile group with my crate layout and then crates. And then in this for loop again, I want to have another if statement that if type is equal to crate, or crates actually, then we want to do something else. And this time we are going to have a slightly different approach. And let me explain why. For the terrain and the grass, we had to cut up a graphic. But for our crates, we only have a single graphic, so we don't have to do that. And this is actually going to make things quite a bit easier. And really, all I want to do in here is to create a sprite, and this sprite is going to be from the class create, something we have not created yet. And this one is going to need 3 different arguments: the tile size, x, and y. And now in my tiles file, I can create this. So I want to create a new class that I call create. And in here, I want to inherit from static tile. And then I still need an init method that needs self, size, x, and y. And then inside of that, we again need our super and init method. And then here, we have to get all the arguments for all of this. So we need a size, we need x, y, and a surface. And now for the surface, literally all that we need is the image of the crate, and there only is a single one. So what I want to do in here is pygame.image.load, and then the path to the crate is this one here. So we go up a folder, we go to graphics, terrain, crate.png. And then this has to be convert alphabet. But now for this one, we do have a problem. And let me explain why by drawing. So right now, our tile looks like this, and it is 64 by 64 pixels. And this is working perfectly fine for both the grass and the terrain. However, for the crates, it is not going to work, because the crate is not as high. It's only, I think, 48 pixels high, and it's also not as wide, so it's only something like this. So the crate is not going to fill the entire space of the tile. And if we didn't account for that, we would have a problem, because Pygame always puts stuff in the top left. So by default, our crate would start here. And since it doesn't cover the entire height, it would kind of float in the air, which, well, would look very, very silly. So we would have to account for that. But I guess let me first do it without the offset so you can see what I'm talking about. And without the offset, this is actually all we needed. So I can go back to my level and make sure I import crate. And now this should already be working by itself. So down here, I can create a crate. So we need self.create sprites.update, self.world_shift, self.create sprites.draw, and self.display surface. And now let's try this. And there you can see what I'm talking about. Our crates are floating in the air, which, well, looks very, very silly. So we have to give them an offset. And this is going to happen in this class as well. And essentially, all I really want to do is to create an offset y. And this in my case is going to be y plus the size. And let me explain what this means. Let's say again, this is going to be our tile with 64 by 64 pixels. Now, the top line here, let me use a different color for this. The top line here is going to be y, all the way at the top. And from that, we add the height or the tile size. So once we add the size, we are all the way at the bottom here. So this point here is going to be our offset y. Now, why is this point useful? Well, now we can override the rectangle argument and just place the mid-bottom or bottom right, and then our rectangle would start down here instead of the top left. And that way, our rectangle would always be at the bottom. And we haven't done an exercise in a while, so this might be a good thing to do now. And essentially what I want you guys to do is to override the rectangle argument and place the crate at the bottom. Could be the bottom left, bottom right, or mid-bottom. It's really up to you. So first of all, I want to override self.rect. And in here, I'm going to need my self.image.getRect. And in my case, I'm going to go with bottom left. And in here, I need a tuple with x and y. And x in this case is just this x here, the one we already have. And y is just going to be my offset y. And that way we are moving down our crates a tiny bit. So it is actually at the bottom of this tile, not at the top anymore. And now, back in my main file, this is looking significantly better. So we are making progress. Cool. Now, next up, we have a minor problem. And let me explain why. So right now, we place the terrain, the grass, and the crates. And all of these are static. However, for the rest of the tiles that we have to place, they are all animated. So we have to create a basic animation. And this is going to involve a couple of steps. Number one, we have to import lots of different art assets. And we're going to write a specific function for that. So we don't have to manually import a ton of stuff. Then next up, we have to figure out a basic function to animate something, which I already covered in a previous video, but I will go over it again, just in case you haven't watched that one. And all of this is going to happen in its own separate class. So this is what we also need to create. So a couple of things to work on. And let me do all of this in code. It's best to explain this while I go along. So here we are back in our level class, and I want to go to my tiles. And in here, I want to create another class. And this is called animated tile. And this one is going to inherit from tile. So we don't have to reinvent the wheel. And we still need an init method that needs self. We need size, x and y. And now I need a path. So in the previous examples, we always had a surface because we only had a single image. But for an animated tile, we want a path to a folder with multiple images. And we will then loop over these images later on. And in here, we still need our super init method that needs a size, x and y. And then the first thing we will need in here is self.frames. So all the frames we want inside of this class. And this is going to happen inside of a function that I called import folder. And this one is going to have a path. And now we have to create this import folder. And I want to do this in my support.py file. And let me minimize all the other stuff. We don't need those. And let me place this one all the way at the top. So I want to import folder, and this needs one argument, which is a path. And now we have to figure out the function to import all the images inside of a single folder. And Python has a specific module for this sort of thing. It's called OS. So I want to import OS. However, I only want a single method of OS. So there's no point importing all of it. So what I want is from OS import what is called walk. And let me put it next to the others. And walk is basically giving us the ability to walk through file paths and get the names of files inside of a folder, which is very, very useful. And essentially, you're going to use walk in a for loop. So let's say for now for information in walk, and walk just needs a path. So what folder we are looking at. And for now, let me just print what we are going to get. So now we have a basic import folder. And if I go back to my tiles, when we create this, for now, I just want to print what we are going to get. So back in the level, let's say for now, I want to create my coins. And for that, I need a coin layout. And this one is going to work just as the ones before. So import CSV layout, then level data, and in here, it is called coins. And then I want self.coin sprites is going to be self.create tile group. We need the coin layout and then the string coins. And now down here, I want to create another if statement that if type is equal to coins, then for now, I want to create a sprite that is an animated tile. And I have to import this one as well. So animated tile. And now we need the arguments, which is size, x, y, and path. And size is just going to be tile size, X and Y we already have. And now we are going to need a path. And for the coin for now, I'm going to work with the gold coins. So we need to go one fold up, then to graphics, coins, and gold. And inside of gold, we have 4 different coins, each for a different part of the animation. So now, once we run our level class, we should be seeing something. So now we can actually work with animated tile. So I want to go back to my tiles file. And in here, now we have to work with animated tile. And the first thing that I did forget is we have to import from support, import folder. And now let's actually try if this is working. So let me run the code in the main. And now at the bottom, we can see a couple of bits of information. And let me go back to support. So right now, all the stuff you see at the bottom is this information here. And there are 3 parts that are important here. We first get the name of the folder we are importing. And this we don't really care about because we already have it. Now the second part, this bit here, is any kind of folder that is inside of this folder we are targeting. And in this case, there is no folder inside. So this list here is empty. But then finally, this list here is what we actually care about, because these are the different images that we want to loop over. So essentially, we get 3 informations back. And we only really care about this one here. So we can safely disregard all of this stuff because we don't care about it. So let me close all of this. So instead of information, I get the folder name, I get subfolders, and I get the image files. And well, I don't really care about the folder name and the subfolders. So I'm going to replace them with an underscore and a double underscore. And this way I indicate that this information just isn't relevant for me. And now image files is going to be a list of different images. So I can add another for loop that is going to be for image in image underscore files. And in here, I get the name of each file. And it is really important, I am only getting a name. I'm not actually importing anything just yet. But the name of the file we can use to create the full path. And well, let's call it the full path. And literally what that is going to be is I'm going to get the path I already have. And that's the path to the folder. Towards that, I'm going to add a slash, and then we are going to add the image. So literally all we are going to do is we get the path we already have, and we are adding the image name towards it. And that way we are getting the full path to all of the files inside of this folder. And that information we can now use to create a new surface. And now all we need is pygame.image.load and pass in our full path and then convert alpha. And this way we don't have to manually import every single one. We just do it all in one function. So with that, I will get all of my surfaces, but I also want to return them. And for that, I'm going to create a new variable. Let's call it surface list. And this for now is just an empty list. And inside of this for loop, I just want to get my surface list and append my image surface. And then at the end of this function, I just want to return my surface list. And that way, we should be getting all of the images inside of this one particular folder. And I could be running my code now, and well, let's actually do this. And it is working, so we don't get an error message, but right now we don't use any of these images. So, well, we at least know it's working. But now I can go back to my animated tile, and now I can work with this a little bit more. And in here, I want to create 2 new attributes. The first one is going to be self.frameIndex. And by default, this is going to be 0. And then I want to override self.image. And this is literally just going to be self.frames. And then we pick one index with self.frameIndex. And that way we are going to have an actual image. So now what I can actually do is down here in my level class, I can add another part that is called coins. And this is just going to be self.coinsprites.update, self.worldshift, and self.coinsprites.draw, self.displaySurface. And now let's try this. And indeed, we can see our coins. They're not animated yet, but that is going to come in just a second. But at least we know it's working. Although, if you look closely, and let me set the world shift to 0, so we can see a little bit better what's going to happen. So now we can see the entire thing static. And right now, there's one problem with our coins. And think of what the position of each gold coin is. That you can see, for example, for the crate, the 64 by 64 tile is roughly going to be something like this. And for our crate, we place it right in the bottom left. And for the coin, you can see it's way too far to the top left. So later on, besides animating it, we also have to move it something like this. So it's not in the top left of each tile, instead it's in the middle of it. That is something we are also going to work on. But I guess step by step, let's first animate this thing. And let's talk about how animating this is going to work. And I actually made a separate video on how to animate something. And also, if you followed the previous video, this is also explained in there. But let's go over it really quickly. Essentially, what we want to do in our animated tile is to pick a different frame from self.frames and set it as our self.image. And to achieve that, we are going to update self.frameIndex. So in the most basic sense, all we have to do is update our self.frameIndex with +=1, and then use that to get another image from self.frames. However, the problem with this setup is that our animation would run way too fast, because we are picking a new image every 60 milliseconds. It's just far too fast. So instead, I don't want to update my self.frameIndex by 1. I only want to update it by 0.15. And then we are only going to pick the next index once we are reaching the next integer. So once we're reaching 1, 2, and 3, and so on. And I guess the other point you do have to remember is that self.frames only has 4 different frames inside. So once we're reaching the end of that, we have to set our frame index back to 0. But that also isn't a big problem. Let's actually implement this. So here I am back in my tiles, and inside of animated tile, I want to add another method that is called animate. It does not need any arguments. And in here, I want to create the logic for our animation. And the first thing, I want to get my frame index and plus equal 0.15. Now this number I have picked only because it looks good. You could choose another number if you think something else looks good. It's perfectly fine. Now, once we have that, all we need to do is get my self.image and assign this to something new. And again, I want to get my self.frames and now self.frameIndex. So we are essentially updating our self.frameIndex by a tiny number, and at some point we are picking a new self.frames. But now there are 2 problems. The first one is that we can only select something by index if we have an integer. And right now, self.frameIndex is going to be a double. So we have to turn this self.frameIndex to an integer, which is very easy. All we need is the int method. So this was a very easy thing to fix. And next up, the problem is that this self.frames only has 4 frames inside. So we have 0, 1, 2, and 3. But if we keep on running this self.frameIndex, we would very, very fast end up with a number like 4, 5, 6, and so on. And as a consequence, we would get an error. So ideally what we want to do is after we have reached 3, we want to move back to 0. Or to make this even more dynamic, once we reach the end of self.frames, we want to go back to 0. And this we can also achieve quite easily. It's an if statement. So try to write the if statement yourself that once we have reached the end of the length of our frames, we want to set frame index back to 0. All right, so we do need an if statement. And what I want to check, if self.frameIndex is greater or equal than the length of our self.frames. And if that is the case, self.frameIndex is going to be 0. And that is all we needed to animate this kind of thing. So with that, we can now create an update method. And be aware here, let me scroll up. Once we create this update method, we are overwriting this update method. So once we create update, we also have to cover this part here. It's very easy to forget. So let's first just copy the entire thing. So self and shift, and I just want to copy this line here so our coins move along with the level. But besides that, and let's put it right before, I also want to call self.animate. And well, that should be all we needed. Let's go back to our main file and let's try this now. And there we go. Now we have animated coins, which is looking quite nice. But now we have the other problem, that the coins have this weird offset to the top left. And this we can work on quite easily. But in my case, I have a couple of animated tiles. So instead of updating this here to adjust it for the coins, I'm going to create a whole new class. That is going to be coin, and this one will inherit from animated tile. And that way we can reuse this animated tile for the palm trees later on as well. So we don't have to recreate this entire thing twice for the coins and for the palm trees. But in here, I just want to call my init method again. And in here, the arguments are going to be self. We need a size, we need x, we need y, and we are going to need a path. And now, as always, we need super.init. And in here, I want to pass in my size, x, y, and the path. So for now, we are basically just recreating this entire thing. And once we're calling this, we basically have all of this copied. And the only real update I want to make is to self.rect. Because by default, we are placing this animated tile in the top left. But for the rect, I want to place this in the center. So really all I have to do is self.image.getRect. And now I want to get center. And now for the x and y, I want to get center x and center underscore y. So what we now have to figure out is how to get these two numbers. And let me put them as their own variables. So center x and center y. And in here, we can think about what we have done earlier. So when we placed the crate, we used this line here, where, let me draw this really quick. So here's our 64 by 64 tile size. So 64 and 64. And for the crate, we went with the top left and then went all the way down. Okay, that's a bit too far. We went all the way down to here and then placed the origin point of the crate to this bit here. Now for the coins, we do want to do something similar. But now we want to go from the top left, so the point we already have, only halfway down, so roughly here. And then we want to go halfway to the right. And this way, we are going to end right at the middle of our tile. So that's literally all we are going to do. And to achieve that, let's start with x. We first want to get x by itself. So that's the left side of our tile. And towards that, I want to get the integer of my size divided by 2. So this right now would be this offset here. This is going to be our x. And now besides that, we have to get our y as well. And that is also going to be quite easy, because all we need is the same logic. So we need y plus the integer of the size over 2. And now let me delete all of this. This is literally all we needed to place the coin in the center of the tile. Let me actually minimize all of the other classes. It's getting a bit hard to read. So now we have our coin that is basically an animated tile, except with a slight offset. But with that, I can go back to my level, get rid of animated tile because we don't need it anymore, and I just want to use my coin. And now animated tile is going to be a coin. And now, if I run all of this, now we have our coins right in the middle. So this is looking significantly better. Cool, this is also working very well. But now we have one more problem for the coins, because we have two different kinds of coins. We have a gold coin and a silver coin. So in here, I have to add another if statement that if my value, so this value here, is going to be 0, I want to add a gold coin. However, if the value is 1, I want to add a silver coin. And this should be quite a straightforward thing to do. So let's try to do this as an exercise. That I want you guys to add the if statement to either add a gold coin if our value is 0 or a silver coin if the value is 1. And both gold and silver coins are going to have the same coin class. All right, so literally all we are going to need is once we have our coins, I want to check if value is equal to the string 0. And if that is the case, my sprite is going to be this one. And if value is equal to the string 1, then my sprite, let me just copy the entire line, is going to be this one, with the only difference now that we don't pick from the gold folder, we pick from the silver folder. And that is all we needed. So now let's try this. And now we can see silver coins and gold coins. This is also working very, very well. All right, so with that, we have already quite a few different elements. And I guess we can just keep on going. And next up, let's start working on the foreground palm trees. Let's call it FG palm layout. And this one, again, is going to be import CSV layout level data. And in here, I have called this one FG palms, I believe. Let's actually double check this. So game data, foreground palms, no underscore, and then self dot fg underscore palm sprites, and again self dot create tile group, and in here fg palm layout, and I've called this one fg palms. So now we have to do the exact same thing for palm trees. So this is going to be another if statement that if type is equal to fg palms, then I want to create another sprite that is now going to be from the class palm. And this is going to be very similar compared to the coins. So again, we are going to need a tile size, we need X, we need Y, and then we are going to need a path. And for now, let me go with this one here, where we have graphics.terrain.palm small. Although later on, we also have a large palm tree, so this we will have to adjust for, but step by step. So first of all, we have to create another class in our tiles, and this is going to be class palm tree, or just palm. And this one is also going to inherit from animated tile. And in here, we again need an init method that needs self, size, x, y, and a path. And then inside of that, as always, we need our super.init, and we need size, x, y, and a path. Let's just leave it at this for now, although later on, again, we will have to create an offset, just like we have done for the coins, but step by step. So back in my level, once I have this, I also at the bottom want to create a foreground palms, and this is going to be self.fg palm sprites.update with self.world_shift and self.fg palm sprites.draw self.display surface. And well, let's just see how this is going to look. So if I run this, we are getting an error because palm is not defined because I am not importing it. So palm. Now let's try this. And now we have animated palm trees, but they are all a little bit too far down. So you can see it especially in the top right. So in here, it's very obvious the palm trees are way too low. And the reason for that is that we have set the origin point in our tiled editor. This is the origin point we actually placed. But in Pygame, we always place the entire image at the top left. So we placed it here. So literally all we have to do is give each of these palm trees an offset to move them up by a certain amount of pixels. So all I have to do in my level, I want to give this one an offset here, because later on we have the small palm trees and the large palm trees, and they might need different kinds of offset. So in here, I'm going to add another argument. And for the small palm tree, this was 38. And this is going to be a Y offset. So back in my tiles, I have to add an offset in here. And now in here, I have to again create an offset Y. And this is going to be Y. And this time it's minus the offset. So this is very similar compared to the offset for the crate, except the difference now is that we are moving upwards, not downwards. And we are using a different number, but same principle. But now we just need self.rect.top left. And this is then going to be X and the offset Y. So we are essentially moving the entire rectangle up by a tiny bit. And well, let's try this now. And this is looking significantly better. And you could even be fancy here and give each of them a slightly more random offset to make it look more chaotic, but well, that's something you can do on your own time. And now the last thing I'm going to need, just like I've done for the coins, there are different kinds of palm trees. And I believe, unless I got it wrong, that if the value was equal to the string 1, then we want a small palm tree. And let me copy this. And if the value was 2, we want a palm large. And the offset for this one, for me, was 64. And let's try this. And this does not seem right. And I think the reason is this should be 0 and 1. And now let's try this. And this is looking much better. So now we have all of our palm trees and they're animated by default. So this is also quite nice. Cool. And now that we have that, besides the foreground palms, I also want background palms. And this is again going to be another section. Let's call this background palms. And in here, FG palm layout is going to be, let me actually just copy all of this, because we're only going to change one letter for most of this. So this is BG palm sprites, self.create tile group, BG palm layout, and BG palms. And now inside of this while loop, I want if type is equal to BG palms, I think, yeah, BG palms. And in here, I just want to create a sprite because we only have one type of background palm. And here we can recycle our palm class, and we actually need the large one. And I've called this one palm BG. And now all we have to do is to draw this thing. Let's call it the background palms. And I again can copy all of this and change this to a BG. And this should be all we needed. So now let's try this. And there we go. Now we can see our background palms. Although the problem right now is they are in the foreground. So all we have to do is to grab all of this and move it up behind the terrain. And now let's try this again. And there we go. Now this is starting to look much better. And in here, you are starting to see some problems, that we have a couple of overlays. So especially this bit here, where the background of our coin is black, and this overlays the background palm tree. Sorry, it's very hard to see since I have drawn of it. But here, for example, you can see the palms cut off. You can see the same thing here. You can see the same thing here. You can also kind of see it here. And the reason is because we don't have proper alpha values. And as a matter of fact, let me actually change the background color from black to gray. And now let me run this again. And now we can see the problem a bit more distinctly. That we have lots of part where we didn't set the alpha properly, so we get some black backgrounds. And I guess here you can see it the most, but also when you look a bit more closely. For example, at the terrain here and here. Even for the terrain, we have some black background stuff that we do want to get rid of. Unfortunately, this isn't all that difficult to fix. And the main part, if I go back to my support.py, when we import the cut graphics, this new surface here doesn't have any alpha values. So all the stuff that isn't filled by a tile is going to be black. Fortunately, this can be fixed easily. All we need is to give it one more attribute, and that is called flags. And in flags, you can give surfaces different kind of values to make them behave differently. In my case, I want to give it the flag of Pygame src alpha. And this is going to set all the pixels that aren't being used to invisible, so they're not going to be black. And now let's try this again. And this is looking significantly better. So a very easy fix, but looks very ugly if you don't cover this. But now we have our basic setup. And there's one more problem with the layer setup. So right now, the crates are in front of the grass, and I want them behind of it. A fairly small detail, but it did annoy me a bit. So now if I run it again, now this is looking much better. So for example, if you look down here, now the grass is in front of the crate, which I think looks a bit better. Now there are two more things I think that we have to add. One is the enemies, and the other is the player, or at least the player head at the end of the level. And I guess let's start with the enemy. That's going to be the most important part. So in here, I want to again set another section, and let's call this the enemy. Just keep it at enemy. And then here, I again need an enemy layout. This is going to be import CSV layout, level data, and this one I have called enemies, I believe. Let's double check. Enemies, yeah, this one. And then self.enemy sprites. And here again, self.create tile group. For the enemies, it's going to work exactly the same as all the other tiles. And we need enemy layout, and I've called this enemies. So far, no difference. And now in here, if type is equal to enemies, I want to add another kind of sprite, and this sprite is going to be enemy. And we are again going to need our tile size. We need X and Y for the position, and let's leave it at those for now. Now, for the enemy, we are going to use a lot of logic that we have created in here. But I think the enemy stands by itself, so it should be in its own file. So let's create a new one. And I have called this one enemy.py. And in here, I first have to import a couple of things. So Pygame, we always need. And besides that, I want from tiles import animated tile. So I am going to keep this animated tile and just add a few more extra parts to it, so we don't have to reinvent everything. And now here, I want to get my class enemy, and this one inherits from animated tile. Now in there, we again are going to need an init method that needs self, size, x, and y. All the arguments we passed in here. And then we are going to need a super.init method. And this one is going to need size, x, y, and a path. Now, the path is quite easy because there's only one path for the enemies. And that is going to be this one here. So we go up a folder to graphics, enemy, and then run. The enemies only have a single one. And we only eventually going to flip this once in a while, but that's all we need. And I guess for now, we can just keep it like this. And let's actually import it. So in my level file, from enemy, import enemy. So now we can use this enemy, and we have our sprite group, and then we can also draw all of this. So self.enemy sprites.update, self.world shift, and self.enemy sprites.draw self.display surface. And now let's try all of this. And there we can see our enemies. And right now they are in front of the palm trees, which I don't like very much. So I want them to be behind the palm trees, behind the crates, and behind the coins. And also, I guess, behind the grass. So I can just take all of this and move it just behind the crates. And now let's try this again. And that is looking better. But now we have the same problem we had for the crates. That, for example, for this guy here, let me use a better color, that there's this massive offset between the bottom of the enemy and the ground. So it looks like they're floating, which is something we do have to address. And fortunately, it's not that hard to fix. All I want to do is get my self.rect.y and add something to it. And this number now I have to find. And it's actually quite a simple thing to achieve. And let's say this here is again my 64 by 64 tile size. And right now our enemy only covers, let's say, roughly this distance here. That's a terrible straight line. So I want to figure out what this distance here is going to be. And well, all I really have to do is to get this number and subtract this number from that. And that way, what's left is this distance here. So all I want to get is my size minus self.image.getSize. So this is going to give us the x and the y dimension of our image. And we only want the y dimension. And now if I run this again, now our enemies are nicely on the floor. So this is working quite well. So now what we have to figure out is how to move this enemy. And well, for that, I'm going to add a method that I will call move. And in here, literally all we need is self.rect.x plus equal, let's say, self.speed. And that means we have to give this enemy self.speed. And I guess the value here should be something random. So from random import randint. And let's say I want a randint between 3 and 5. Should be good. And this would always mean our enemy, when it's starting, is moving to the right. And then obviously we also need an update method that needs self, and again we are going to need shift because now we are overwriting the update method from this animated tile. So the first thing we are going to need is self.rect.x plus equal shift. Then we need self.animate. And be aware here, self.animate comes from the inherited animate tile. The reason here is we have to call it because we're overwriting animate. So you can't see it in this class, but it does exist. Then we also need self.move. And that should be all, at least for now. So let's see if this is working. So let me run the code. And now I can see all of my enemies moving to the right at different speeds. So this is indeed working. So I guess the one thing we have to work on now is if an enemy is moving to the right, we want to reverse the image. So let's call this reverse image. Doesn't need any arguments. And all we need in here, if self.speed is greater than 0, so we're moving to the right, then self.image is going to be pygame.transform.flip. And we just put in our self.image in here, and then true and false. So in case you haven't seen this one yet, all it does is it takes a surface and then it flips it either in the x-axis or in the y-axis. And in my case, I only want to flip the x-axis. And now all we have to do is to call self.reverseImage and we should be good to go. So let's try this now. And this is looking significantly better. Now, obviously, our enemies are not reversing. And this we have to start working on now. And this is going to need two major parts. First of all, our enemy class needs a method that reverses the speed. And that is the really easy part. Because all we need is, let's call it reverse, doesn't need any arguments. And all we're going to do in here is self.speed multiply equal -1. So as soon as we call this method here, our speed is going to be reversed. Now the more tricky bit is, when do we call this method? And for that, we have to go back to our level. And this is what we created ages ago in the tiled editor. Those were the big red squares that we created back then. And I want to place them on our level as well. But, well, we just keep on doing the same. So now I want to add a constraint. And let's call this a constraint layout and import CSV layout, level data. And this one I have called constraint. I believe it is constraints, this one. And then self.constraint sprites is going to be self.create tile group and constraint layout. And then the string is going to be constraint. And now again, we have to add one more if statement in here. So if type is equal to constraint, and if that is the case, I want to create a sprite, and it doesn't really matter what we put in here. I'm just going to go with tile. And we need tile size, X and Y. And this tile we already have. This is our original tile in here. And since we're not going to show it anyway, it really doesn't matter what we put in here. So this way we would get a basic tile. And now what we have to do all the way down here, let me actually put it right below the enemies. I think it makes the most sense there. So self.constraint sprites.update and self.world_shift. And let me put it right above that. So now we have these tiles in the world and we're also updating them so they're shifting along with the level. However, we are not drawing them. As a consequence, you can't see them, but they do exist. And that's the important part here. And as a consequence, we can use these blocks to change the direction of our enemies. And this is going to be another method in our level class. And let's call this enemy collision reverse. Maybe not the greatest name, but I guess it's okay for now. And it doesn't need any arguments besides self. And all we want to do in here is for enemy in self.enemy sprites. So we are checking all of our enemy sprites. And what we want to do with them is if pygame.sprite.sprite collide, we want to check with the enemy and self.constraint sprites, and then false for the final argument. And if that is the case, I want to call enemy.reverse. So essentially, all we are going to do in here, we first cycle through all of our enemy sprites. So literally all of our enemies. So that's step number 1. Step number 2, this one here, is we check if any of these sprites is colliding with any of these constraints. And if that is the case, we want to call enemy.reverse. And in case you're wondering, this false here is called doKill. So do we want to destroy the constraint if there's a collision, which we do not want to do. And well, with that logic, we have all we need to reverse the player. So now I just have to call it, and let's put it right below the constraint sprites. So self.enemy collision reverse. And this should actually be working now. Let's try. And we are getting an error. That there's no such file or directory, that we don't have the CSV file, apparently. And the reason for that is, if I go to my game data, I have called this constraints. So now this should be working, and there we go. Now we have our enemies all moving nicely along, and we can control very much of where they are going. So this is also working really well. Cool. We are making some good progress. Now there's only one more layer we do have to take care of, and that's the player setup. And well, most of the logic here is going to be identical. Although there's a problem now, that we have created the entire player in the previous video. So if you didn't follow this one, you probably don't have access to the player. So for this tutorial, I am not going to place the actual player, I am only going to place the goal of the player. But if you have watched the previous tutorial, at the end of this tutorial, I'm going to integrate the first tutorial with this one, so we have a proper game. But for now, I'm only going to place the goal, not the player itself. That will come later. But, well, all we have to do, if I go back, we kind of have to do the same setup that we have done with the player. And let me do it all the way at the top. So this is going to be my player setup. And here, as always, we need a player layout. And this is going to be import CSV layout, level data. And I have called this one. However, now we have a minor problem, because this method here, self.createTileGroup, is always going to return a whole group. But for the player, I want a group single. And I also want a group single for my goal head. So unfortunately, we can't really use this method here anymore. We have to approach this slightly differently. So instead of using a method, I'm going to create self.player. It's just going to be pygame.sprite.group single. And then self.goal is also going to be pygame.sprite.group single. That's not how you spell that. And now that we have those two, I am going to call another method that I call player set up. And this one is going to need the player layout. So now we have to create this method here. And this is going to be very, very similar compared to what we have done here. So I can actually literally just copy it, although generally not the best practice, but I guess in this case it's fine. So set up player, I believe I called it, needs self and layout. Or did I call it player setup? I did call it player setup. Okay, player set up. And now in here, we can just paste all of this, because we are essentially going to do the same logic. So I still want to do all of this. I still want to do all of this, but this value I do want to change, because in this layout, there's only really two values I care about. Either if the value is 0 or if the value is equal to 1. So 0 is going to be the player and 1 is going to be the goal. And I guess I can put all of this before the if statement. Now, for this value here, we would do something with our player, which we do not have right now. So let me for now just add a print statement, player goes here. But for value 1, we can create a sprite. And this is just going to be a static tile. And for that one, we are going to need our tile size. We will need X, Y, and then a surface. Now the surface we don't have right now, so we have to import it. And let's just call this add surface. And all we need here is pygame.image.load. And then the file path we are going to need is this one here. So graphics character head.png. And don't forget to convert alpha this as well. And then we can pass in head surface. And now do not forget, we need our self dot, I think I called it goal sprite, all the way to here. Oh, just self.goal. So self.goal.add and I want to add my sprite. And now all the way, let's put it all the way at the bottom. Let's call it the player sprites. And then here, self.goal.update, self.world_shift, and self.goal.draw in self.displaySurface. And now let me run this, see if we have an error, and we do have one. And the error is, oh, I forgot the double colon. Now let's try this again. And there we go. And we can see player goes here, but it's just a print statement, so we can't see it. So let's move the entire level, let's say by -6. And let's try it now. So now all of this is working really well, and we should be seeing the head in just a second. And yeah, we can indeed see it. So this is also working quite well. Cool. So with that, we have all of the layers we needed to import. And that did take quite a while, but well, when it comes down to it, the logic here really isn't all that complicated. We just had to repeat it multiple times. And you could probably simplify this quite a bit to write less code, but I guess for a tutorial, this was the best approach. So with that, we are almost done. There are a couple more things that I do want to add. And that is, I want to add a sky, some water, and some clouds, so that we don't just have a plain gray background, which looks kind of ugly. And each of those is going to be its own class. So we have a sky class, a water class, and a cloud class. And well, all of those are not particularly complicated, so I guess let's jump straight into them and let's have a look. So here we are back in our main file, and what I want to do is to create another Python file, and I call this one decoration.py. And in here, let's start with sky. Does not inherit from anything, but as always, we need an init method. And in here, I want to have self and what I called horizon. And this is essentially going to be a Y position where we have the switch between our ground tiles and our sky tiles in the background. And in here, we have a couple of files we need to import. And usually we just imported an entire folder. But in this particular case, I want to work with each of them in a bit more detail. So let me just copy all of the files. So we have self.top, self.bottom, and self.middle. And each of those are inside of our sky folder. And these are very simple images, so it's really nothing complicated happening in here. And let me explain how I am going to use them. So let's say this is our entire game window. And right now, each of these tiles is 64 by 64 pixels. So right now, for example, one of those would look something like this. And essentially what I'm going to do is I'm going to take this tile and stretch it to the entire width of my game window. And then I'm just going to copy each of these tiles multiple times. And once I reach this horizon tile, I'm going to switch to another tile. So all of these are going to be the top tiles. Then at some point, let's say here, we have the horizon tile. And then below the horizon tile, we have the bottom tiles. And that way I can very easily create my sky. So the first thing I have to figure out is how many vertical tiles I actually need. And fortunately, this I already have, because if I go to settings, it's this number here. So all I really have to do is import it. Hence, from settings, import, I think I called it vertical tile number. And also, what I did forget, import Pygame. So now we know how many vertical tiles we need. But besides that, we also want to know self.horizon is going to be horizon. So at what point do we want to switch between the tiles? So let's put all of this right at the beginning of the class. And now let's add this in another section here. I want to stretch all of these tiles. So essentially what I want to do, for example, with the top tile, I want to get pygame.transform form.scale. And then here I have to pass in two arguments. The first one is the surface, and then a tuple with the x and the y dimensions of how I want to scale this surface. Now in my case, the surface is going to be self.top. Then for y, I want to keep this at 64, or rather I want to keep this, like in my settings, at my tile size. So I am also going to import tile size. But now for the x, this should be my screen width. And that means I also have to import this one. So with that, I have all I need for my top. Now, really all I have to do is copy this twice and change this to bottom and middle. And this is also going to be bottom, and this would be middle. And that, I think, is all we needed. Yeah, that looks good. And now once I have that, all I need is, let's call it a draw method with self, and we need this surface I want to draw on. And that way we can use it inside of our level class. And well, all I need now is for the row I want to work in range, and the number here is vertical tile number. And now in here, as always, we are going to need an X and a Y position. Although in this particular case, X is always going to be 0, so we can just skip this one entirely. And for Y, all we are going to need is the row multiplied by our tile size. So this is essentially the same logic we have always used, except only in one dimension. And now what I could be doing is get the surface dot blit and then self dot top for the surface and for the x and y dimensions, and y is going to be, well, this y here, the one we already have. And this would fill our entire surface with one color. And let's actually see if this is working in the first place. So back in my level class, I want to create the sky. And I guess we can put this all the way at the bottom, and I have called this decoration. And in here, self.sky is going to be sky. And as an argument for now, let's put in an 8. So this would be the horizon line. And to use sky, we have to import it. So from decoration, import sky. And this would then be our sky. And now all we have to do all the way at the bottom is our decoration. And here we need self.sky.draw. And this happens on self.display surface. And now let's see if this is working. And, oh, well, it is working, but the problem here is that we are drawing the sky on top of everything else. And obviously the sky should be all the way in the back. Otherwise we, well, can't see anything. So this is much better, and this is feeling significantly better. And I guess for this step here, you could have just filled the entire sky with one color, would also get you the same result. Although in my case, I want to add some more details in here, which is why I haven't done it. But all right, so what I want to do, I only want to use the top tiles if we are below this number here. So right now, this is 8. So I have to add an if statement in here that if my row is smaller than self.horizon, only then do I want to use this line. So now if we run this, our horizon only goes to a certain point. Now after this, if my row is exactly equal to self.horizon, then I want surface.split with self.middle, and we are still going to pass in 0 and y for the position. And let's try this now. And we get invalid syntax because I forgot the double colon again. And there we go. Now in the background we have this horizon line thingy. I guess it's a transition. And finally, we need an else statement that now if neither of these conditions are true, we want self.bottom. And now if we run all of this, we have our proper sky. So this is looking quite nice. Cool, this is working. So this is already finishing up our sky. So I can minimize it and not think about it for a while. And I guess next up, let's create a class for the water. And in here, I again have to create an init method that is going to get self. Then I want a top parameter. And this is going to determine how high our water is going to be, or rather where the top of our water will be in our level. And finally, I'm going to need a parameter that I have called level width. And let me explain why this is going to become important. Let's say this line here is the width of our level. So level width. And essentially what I'm going to do, I'm going to spawn the water in such a way that we start sometime before the level starts and somewhat after the level ends. So all of this is going to be water. And that way I can make sure that the player is always going to see water at the bottom and we can scroll the water along with the level. And if we didn't do this and the water would start with the level and end with the level, the player could look to the left of it and see just nothingness, which would look very, very silly. So we have to keep the water a bit further than the width of the level. And for that, we have to know how wide our level is going to be, which is a fairly easy thing to get. So, right, with that, we have to figure out a couple of parameters. And I guess let's first initiate this water class in our level, and then we can talk about it. So let me actually minimize a couple of things in here so this doesn't get too complex. Okay, now besides self.sky, I also want self.water. And this will just be water. And again, I have to import it. So besides sky, I also want to import water. And now for the height of the water, I want to get my screen height, let's say minus 40, I think is a good number. And then we have to figure out the level width. And I don't think I've imported the screen height in here. Tile size, screen height. So now this should still be working. So how can we get our level width? And this I think could be a really good exercise for you. Try to figure out how wide our level is in pixels. And this should be dynamic. So if the level gets wider or closer, it should still work perfectly fine. Let's put this in a new variable that I call level width. And here's how I approach this. Essentially, when you look at any of our imported CSV files, let's say in my case, I looked at terrain layout. This is essentially just going to be a list that includes lots of lists inside. And each list is going to be one row of our level. And all of these rows have the same length. So all we have to get is the length of one of these rows of any of these layouts and multiply this by our tile size. So in my case, I want to get the length of my terrain layout, and then I just picked the first row. And this then I multiplied with my tile size. And that way, I'm going to get the amount of columns I have multiplied by the tile size, which should then give us how wide our level is. So that's all we needed. So now we can work with the level width. And actually, before we do that, let's run all of this to see if there's an error. And again, I made a mistake somewhere. Let's check decoration water. I guess backend decoration. All right, this here should have a pass for now, so we don't get an error. And okay, it is still working just fine. Cool. So now we have to work inside of this init method. And the first argument I am going to need is the water start point. And this is a number that I want to start one screen width to the left. So our starting point is 0, and I want to go to the left of that by one screen width. So this is just negative screen width. Then I will need my water tile width. And in this case, I know my water tile width is 192 pixels wide. And after that, I need to know how many of these tiles I will need. So let's call it tile X amount. And in here, first of all, I want to get my level width plus 1 screen width. So this is then going to be the pixels, how wide I want my water to go. But this right now is just a pixel, and that's not what I really care about. Instead, I want to know how many tiles I need to fill this entire space. And to get that, all I have to do is put this in brackets and divide it by water tile width. And then all of this I want to turn into an integer. And that way I'm going to know how many vertical tiles I will need. And then finally, I need a water sprites sprite group. And this is just going to be pygame.sprite.group. And well, now all we have to do is to place our water tiles along this position here. And for that, I'm going to add a for loop. So for tile in range tile X amount. And now we need an X and a Y position. And the Y position is the easier part. It's literally just going to be the top. So the number we have specified in here as an argument. That's all we're doing here. And for the X position, all I really want to get is my tile. So this is a number between 0 and whatever we got in here. And multiply this by my water tile width. But this number here would always start at 0. So towards that, I have to add my water start. So this way, we would start at this position here. And now we can just, as always, create a sprite. And all we need in here is an animated tile. So what we created earlier in our tiles. So this animated tile here. And to use it, we have to import it. So from tiles, import animated tile. And now we can use it. And let me copy the arguments we are going to need. So we need size, X, Y, and path. And now for the size, we don't need our tile size. We need 192 because the water tiles for some reason are wider. X and Y are still perfectly fine. And now for the path, I want to get this graphics folder, and this should be a string. So graphics, decoration, and water is the folder I will need. And at the end of this, I want to get myself.water sprites and add this sprite towards it. And that is all we needed. So now I can give this a draw method as well. It needs self, it needs a surface, and this one will need a shift argument because this animated tile expects an update method with a shift argument. So we need that part as well. And well, in here, all we need is self.watersprites.update, and we pass in the shift argument in here. And then we need self.watersprites.draw, and now we need the surface. And that should be covering our water. So now back in the level, I can draw in our run method, I can draw the water on top of everything else. So let's call this water. So self.water.draw. And in here, we first of all need the arguments for surface and then for shift. And again, let me copy them. So first of all, we need the surface, and this is self.displaySurface. And then shift is self.worldShift. So now let's try all of this, and this is working. Cool. The water might be a little bit too high. Let me put it down a touch further down. All of that happened here. Let's say -30. Yeah, still a bit high. I guess you can play around with this quite a bit more. Now with that, we also have our water. Now the final thing that we are going to need is our clouds class. And in here, we again are going to need an init method. It needs self. We're also going to need the horizon line. Then I also want to know the level width. And then I want a number of how many clouds there are going to be. So cloud number. And in here, first of all, I need my different clouds. And since I'm not going to work with them in too much detail, I can just import all of them on its own list. So we can just create another variable. And this I am just going to get from this file here. I just want to import the folder. So I have to import all of this. So from support, import, import, folder, and now import folder. And the folder path I need is this one here. So graphics, decoration, and clouds. And now I need a couple of different arguments. And let me draw this actually. So let's say this here is our entire level. And I need 4 different arguments in total. The first is on the x-axis where our clouds are supposed to start and where they are supposed to end. So this is our vertical start and end number. And besides that, I also want to place my clouds below the top of the screen and then wherever the horizon line is going to be. So only in this line here, I want to have clouds. And once I have this area, essentially what I'm going to do is I'm going to pick a couple of random numbers and place a cloud there. That's all we really need. So let's put all of this on its own variables. So first of all, I need minimum x, and this I've put down to negative screen width. Then we need a maximum or a max x, and I've put this to my level width plus screen width. Then for minimum y, this is the easiest one, it's just going to be 0. And then max y is going to be my horizon. And after I have all of that, I again need a sprite class. So let's call it self.cloudsprites. And in here, this is just pygame.sprite.group. And now we kind of have to do the same thing we have done for the water, this for loop here. Except now we don't really care so much about specific numbers. So let me explain what I'm going to do. First of all, I need a for loop with for cloud in range cloud number. So the random number we specified earlier here to pick a number that looks good for the amount of clouds. And in there, I just want to pick one cloud from this list here. And this is going to happen with random.choice. So we have to import it. Hence from random import choice. And all that choice does is you have to pass in a list and it picks one item from that list. So choice cloud serve list. So with that, we have one cloud available. Now next up, we need an X position and a Y position. And in my case, I want to use rand int. So I want for X a random number between the min and the max X. And for that to work, I need to import rand int as well. So rand int between min X and max X. And then the same for the Y position. So min Y and max Y. And well, that is literally all we needed. So now I can again create a sprite, and this is going to be a static tile. Again, the tile we have created here. So again, I have to import it. And this one, the arguments we need here, let me copy them. We need size, x, y, and surface. And the size here really doesn't matter because we can't touch the clouds anyway. So I just pass in a 0. X and y we already have. And the surface is just going to be the cloud. And then finally self.cloudsprites.add. And I want to add not the cloud, the sprite. And this way, once we initiate this class, we have all of our clouds in place. Cool. So now finally, I need self.draw. It needs self and it needs surface. And also don't forget, we need shift again. And then in here, self.cloudsprites.update. And this needs a shift, and this should be a dot. And then self.cloudsprites.draw. And this should happen on the surface. And with that, back in my level, I can add self.clouds is going to be clouds. And in here, the arguments we are going to need is the horizon, the level width, and the cloud number. And the level width we already have. For the cloud number, I think in my case, I went with 20. Although this is a fairly subjective number. Now, for the horizon, we could have gone with the same number here, but I wouldn't really like for a cloud to be exactly on the horizon line. So this one is a bit more flexible. We can just pass in a pixel number in here. And I guess in my case, I went with 400. And now that we have that, we can go to our run method and let's call this sky. And I want to get self.clouds.draw, self.displaySurface, and I think, yeah, surface and then shift. And then self.worldShift. And now, if we run this, we are getting an error that name clouds is not defined because, as always, I did not import it. So we are really starting to import a ton of different things. It is very easy to forget. But now we have our clouds, which is making the entire thing look significantly better. And I think here 20 might be a little bit on the low side. Let's maybe go with 30, might be overkill. No, still, that looks good. And yeah, I'm happy with that. And all right, so with that, we have finally finished setting up the entire level. And that was a very long part so far. And if you got this far, you should have a pretty good idea on how to use tiled and how to import all of this into Pygame, which has taken quite some time. Now, for the final bit, we have to combine all of this with the player we've created in the previous tutorial. So this is what I am going to start working on now. So let's talk about how to import the player. And fortunately, this shouldn't be all that difficult because most of our basic setup is identical. So let's talk about what we have to do. First of all, we have to import the code for the player and for the particle effects. And then we have to integrate them into our level. Then next up, we have to update our level class so that we can use it to control the player. And then we also have to update the methods for the particle effects so we can check if the player is jumping or falling. And again, for all of this, if you have not watched the first part of this series, you will be completely lost. So just a warning. But all right, let's go first of all to our folder. So here is all the code we have written in the first part of this tutorial. And the only two files I need is particles and player. So I'm going to copy those. And then I will go to my new file and I can just paste them in here. So now we have a ton of different files that we can work with. And the first thing we have to do is to integrate the player inside of our level. So let's go back to my level. So here we are back in the level. And the first thing we have to do is from player import player. And this should be spelled correctly. And let me actually open the player class, this one here. And we just want to import this player. And this one mostly works by itself, at least for now. To move it, we need something else in the level class. And now in the init method, we already have our player group single. So this one is working by itself. And then we have our player setup. And in here, we have to spawn our player. So in here, I want to create a sprite, and this one is going to be my player. And now we need all of the arguments for the player. So in my player, let me copy all of the arguments we are going to need. So we need position, a surface, and create jump particles. Now, position is the easiest. We just need X and Y. This we already have. Then the surface, this is just going to be self.displaySurface. And now we need the create jump particles. And this we earlier created in our level class. So we have to import it. And for that, let me open the previous level class. Here we have the earlier level class we created in part 1. And the one method we do want to get is create jump particles. And this is create jump particles, this one here. So all we need to do is to copy all of this and place it inside of our level class, the new one. And then we can just pass this one in here. And now I guess what we can do is just run the code and see what is breaking first. And well, it's all still working. So that's actually a really good sign. So now we have a player, and we have to add this player to self.player, I believe. Let's see what I called it. Self.player, yeah. So self.player.add, and we want to add the sprite. And then in the run method, I want to add the player. And the player, let's put him right here where we already have our goal sprites. So in here, I want to get my self.player.update and self.player.draw. And don't forget, for player.draw, we need self.displaySurface. And now let's try this. And there again, we can see the player. So this is working quite well. Cool. Now, obviously, it doesn't particularly work well with the level because this one stays in a constant place. And while we are creating the player, let me set the world shift to 0. So it doesn't look too weird. And now let's try this. And now we have our player. So this is already a pretty good start. Now, next up, let me minimize all of this again. We are going to need the two methods that make the player move. So in our original level, this was this horizontal movement collision and this vertical movement collision. And if I open both of them, they were getting quite long. And well, I am just going to copy all of this and paste it in our level. Let's put it right at the bottom here. And let me minimize them for now, so we only work on one at a time. And let's go through in here. These two lines should still work just fine. However, this for sprite in self.tiles.sprite is not going to work anymore because we do not have a tiles class. But what we have instead is all of this. And I don't want my player to collide with all of them. Essentially, I want my player to be able to collide with the terrain sprites, the crate sprites, and the foreground palm sprites. So those are going to be our actual collidable terrain. So we have to use this for loop only with those sprites. And that, fortunately, is quite easy to do. So let me get rid of this part here. And I want myself.terrainsprites.sprites. So this would be one of the groups we need. But now we also want to loop over the other sprite groups. So right now we have the terrain sprites, but we also want to loop over the crate sprites and the foreground palm sprites. And well, all we really have to do to fix this is to add a plus here. So self.create sprites.sprites and then plus self.foreground palm sprites.sprites. And I guess you could put all of this in its own variable. Let's actually do that. So let me cut all of them and let's call it collidable sprites. And that's going to be all of this. And that should be a bit easier to read. And now we have to do the very same thing in our vertical tiles. So let me just copy this line here, go to this part and add it here. It's a very long line and in collidable sprites. And this should actually be all we needed for these two methods. So let me minimize them. And now obviously we have to call them. So in my player sprites, after update, I want to call self.horizontal movement collision and self.vertical movement collision. And let's see what's going to happen if we run all of this. And this is actually working pretty well. Although if I jump, we get particle effect is not defined. So that's something we do have to work on. But without jumping, if I just run around, this is working quite well. So we already have a basic setup. We are getting very close to being done. So now Pygame is complaining that we don't have a particle effect. And the reason for that is in my player class, if I am jumping, I want to create jump particles. And this is a method inside of my level. It starts to become a fairly long code. Let me look for it. Create jump particles, this one here. So right now, whenever we jump, Pygame is trying to create this particle effect, which we don't have right now. However, if I open it, this is the one we imported earlier. So this is just this particle effect. So, well, all we have to do is to import all the way at the top from particles, import particle effect. And now let's try this. And we are still getting another error. Level object has no attribute dust sprite. So let's have a look at that in my level. And in here, we need a dust sprite class, which, well, we can create. And let me close all of this. And I guess we can put this along with the player up here. And I guess let me add another section for dust. And here, self.dustSprite is going to be pygame.sprite.groupSingle. So now let's try this. And now I can jump. And this is already working quite well. Now, obviously, our window isn't scrolling, so the game doesn't fully work yet, but we do have a pretty good start. So next up, let's add the scrolling behavior. And if I go back to my original file, so in here, we have define scroll x. And this I just want to copy. So now in my new level class, I want to paste this as well. And I think most of this should still work just fine. So back when I called all of the stuff for my player, I also want to call self.scrollX, I called it. And it did not have any arguments. No, that looks good. So let's see if this is working. And it does not, because screen width is not defined. So let's have a look. We need scroll X and we need screen width, which we don't have available right now because we are not importing it, but we can get it quite easily. So let's import screen width, and now let's do it again. And this is working now. Cool. So now our level is scrolling with our player. And we can jump on all of this, and this is working very, very well. Now, next up, we are going to need some more minor methods for the landing particles. So if we look at the original level in there, in our run method, we had get player on ground and create landing dust. And those two surround the vertical movement collision. So let me just copy get player on ground and let's paste it in our run method. So right here. And then I also need create landing dust. And this comes after the vertical collisions. And I guess I can add some space between them to make it a bit more readable. Although the code is getting very long, is getting to be very hard to read. But okay, now we have to copy get player on ground and create landing dust. And let me just copy both. Neither of them is particularly long, so I can copy them and paste them in our new level class as well. And now we have to work through those two. First of all, I have to create the attribute self.playerOnGround. So in the init method, let's do it with the player. Actually, let's do it with the dust. So self.playerOnGround by default is going to be false. Then I can minimize the init method, and all of this should now be working fine. And all of this, I believe, is also good to go. So let me save it and let's run all of this. And we do not get landing particles. But we do get the running particles. But we don't get any jumping or falling particles. So I think the problem is that we are not drawing this dust sprite group. So let's check. Yeah, we're just not drawing any of the sprite groups, which is a very easy thing to fix. And what I want to do, below the player, I want to create my dust particles, and here self.dustSprite.update, and this again needs self.worldShift, and then self.dustSprite.draw in self.displaySurface. And now let's try this again. And now we get the jump and the landing particles. And this is making the entire thing look much nicer. So this is working quite well. Cool. Okay, except maybe this part in the level is not particularly well designed, but I'm not going to worry too much about it. So, all right, with that, we have basically the entire thing. And there's only one more thing I would like to add, that, let me minimize this and this, that in our horizontal movement collision, we have self.currentX that I also want to declare in the init method. So let's put it in the general setup. So self.currentX by default is going to be none. And now with all of that covered, let's run this. And this is working surprisingly well. So the level scroll is working, we can collide with stuff, we can jump. Obviously, we cannot collide with coins or enemies, that will come later, but the rest is functioning surprisingly well. And let me try to get to the end. Okay. Yeah, we might need a def state, and oh, I think I made a mistake for the water, so we can fix that. But besides that, this is basically done. So let's go to decorations and let's look at what went wrong with the water. And then here, let's just say we go and double the screen width, and let's see if that makes a difference. Let's actually look at the other side. So the water here works just fine. And if I go to the right, and this is only working because we don't have a def state. And now if I go to the right, now the water is working and goes much further. So, all right, with that, we have our basic level. So I hope all of that was helpful, and I will see you in the next part where we are going to create the overworld. I'll see you then.